Hello everyone and welcome to my Learn Docker Quickly course. In just 2 hours, you will learn all the Docker skills you need to become a Docker master. Okay, so there are a few prerequisites for taking this course. Number one, you definitely need to have an access to a computer or a laptop, or even a Raspberry Pi. Number two, any Linux experience you do have will help you a lot with the course, but it's not a requirement. So even if you have zero Linux experience, you still can take this course, okay? Last but not least, you definitely need to have a passion to learn. If you have a passion to learn, this course will be so easy for you, okay? And that's pretty much the prerequisites for taking this course. All right, let's get started in the next video. Ciao. Hello everyone. So this will be our course overview. We will cover 7 different modules. To begin with, module number 1, you will learn how to install Docker on Linux. Then in module number 2, you will learn how to run your first Docker container. After that, in module number 3, you will learn essential Docker commands. And in module number 4, you will learn how to run an Apache web server container with Docker. Then, in module number 5, you will learn how to run a multi-container application. In module number 6, you will learn how to build your own image using Dockerfile. And finally, in module number 7, you will learn how you can create Docker volumes to persist data. So this is our course overview, 7 different modules. In the next video, we are going to start with module number 1. Let's get started. Ciao. Hello everyone. So to follow along with this course, you will need an access to a Linux system, whether it's a virtual machine on the cloud, or whether you have Linux installed on your laptop, or whether you have a Raspberry Pi, whatever. But you need a Linux virtual machine, okay? So I'm not gonna go over it in this course. However, though, I have attached a free copy of my book, Learn Linux Quickly, okay? So I have attached it in this course for free, and in chapter 1, I actually go over how to install a virtual machine on your Windows or Mac step by step, okay? Very, very easy. So please, if you don't have access to a Linux system right now, I highly recommend reading chapter 1 of my book, Learn Linux Quickly, okay? This will show you step by step detail how to install VM on a Linux VM on your Windows or Mac OS, all right? Until then, see you in the next video. Ciao. Hello everyone. So in this video, I'm going to walk you through the process of creating an Ubuntu virtual machine on Oracle VirtualBox software, okay? So the first thing we need to do here is just go to your browser and then search for Oracle VirtualBox download. Then, as you can see here from the first result, click on it. Now I'm running Windows, so I'm gonna choose Windows here. But if you're running Mac OS, then you can click on here. If you are running Linux, then you can click on here as well, and Solaris, and so on and so forth. So click on Windows, and then it will install the VirtualBox or download the VirtualBox installer. So I'm just going to cancel because I already did that. So after it downloads for you, click on it and just go through the defaults, and this will install Oracle VirtualBox on your machine. Then as you can see here, this is my Oracle VirtualBox. I click on it. As you can see, it doesn't have anything just yet. So you can add a new virtual machine, create a new virtual machine. But before you create a new virtual machine, you need a source, right? So let's go back to the browser and then search for Ubuntu download ISO. So, or just go to ubuntu.com, for example. Let's go to ubuntu.com and then go to the downloads. As you can see, downloads here, desktop. You will always find two versions: the long-term support, which is more of a stable and well tested and a stable version, and then you have the latest and greatest that Ubuntu has to offer. Of course, you are free to use any other Linux operating system or distribution, to be precise. So you can use Fedora, OpenSUSE, Kali. You can use Red Hat, CentOS, whatever you want to use. It doesn't really matter, okay, for this course. But I'm gonna use Ubuntu because it's kind of like very well known, very beginner friendly, very nice. You can even use Debian if you want to. Okay, so you are free to choose the latest one, but I'm just gonna go with the very well tested and stable version. So the long-term support here, LTS, and then just go ahead and click on download. It will download your ISO file. This will take a long time, of course, so I'm not gonna do it. I already did it before the video. I'm just gonna cancel, but you need to just wait for the 2.7 gigs to download or whatnot. Okay, so after you download it, I'm gonna exit. So it did download in my download directory here, of course. So if I search Ubuntu, it should come up. Here you go. This is the Ubuntu ISO image that I downloaded. Now I have all the ingredients to create the Ubuntu virtual machine. So the first thing I will do here, open VirtualBox, as you can see, click on New. Then I'm just gonna call it All Safe. The reason I'm saying All Safe here because I'm a big fan of Mr. Robot TV series. If you know what is Mr. Robot, you will know what is All Safe, where Elliot used to be working. Okay, so I'm just gonna call it All Safe. You can call it VM1, VM2. It doesn't really matter, right? The name here is just a preference. The type is Linux. Here, of course, the path where you want to install or you want to store that VM. And then I'm just gonna say Ubuntu here. Where is Ubuntu 64-bit? And then next, I'm gonna give it a couple of gigs here. So 2048 megabytes. This is like equivalent of 2 gigabytes. That should be enough. If you can go over or greater or bigger, I mean, of course, but don't go less than 2 gigs of RAM. It can be glitchy and freezing and stuff. All right, so next, the hard disk. I'm gonna create a virtual hard disk now. Yeah, VDI. I'm just gonna choose the default VirtualBox disk image, dynamically allocated. I'm gonna just make it fixed because it's often faster to use. I'll give it 20. 20 gigs is good. All right, and then create. So this is creating the disks and assign it to the virtual machine. Few seconds remaining. Hopefully it goes smooth. Hopefully it goes well. All right. We're just gonna wait for it a little bit more. Awesome. So now the virtual box, the machine here is created. So let's start it. And then we have to specify our ISO image. As you can see here, it's powered off. Just taking some time. Keep spinning and spinning and spinning. Okay. Why is it glitchy like that? Just let me close it. Oh, here you go. So it created it behind the window. So now I'm gonna, it will ask you for the select startup disk. So I'm just gonna browse and then go from add and then go to your download directory, choose your ISO image, choose. Okay, so start. This will boot up the ISO image. And let me just go to the settings here to make everything more visible for you. I'm just gonna go 300%. Okay. 300 for the display here. All right, now you can see what I'm doing. All right, so yeah, it just started the or booted up the ISO image or loaded the ISO image. So now we can actually install Ubuntu. Amazing stuff. All right. Good, no errors found. Of course, the process is much, much easier when you're dealing with a cloud provider like Azure or AWS or Google Cloud. We're going to see the difference, a lot of big difference when creating VMs locally here than with the cloud. The cloud is much easier, much faster. You don't have to go through all this headache, but just to give you real life experience here, okay? Okay. Just waiting to start up. All right, okay, we are good. Now let's just, so we're gonna need to start the installer for the Ubuntu. I like that graphic. I think it's it is like a cougar, or that's like a jaguar, more of a jaguar. All right. So as you can see here, it already. So you wanna try, if you wanna just try Ubuntu, you can click on try Ubuntu. But just we wanna install it. So just click on install. Okay, I'm gonna just choose the default here, English US for the keyboard layout. I'm just gonna accept the default. You can do normal installation or minimal installation. I'll just do normal. Download updates while installing Ubuntu. I'm just gonna go with the defaults here as well. All right, yeah, erase disk and install Ubuntu. Just click on install now. So as you can see, I'm basically just going next, next, next. I'm not doing any crazy configuration here or anything like that. I'm not doing partitioning myself or not doing LVMs. Okay, this is where I am right now, Regina. Of course, it should pick up your location. So continue. Regina is in Canada, Saskatchewan. So the name, I'm just gonna call it Elliot Alderson. You can see I'm obsessed with Mr. Robot TV series. So here you can put your name if you want, of course. The computer name, I'll just call it AllSafe, which is a company that Elliot used to work in. And the username will be just Elliot, small case letters. And I'm gonna choose a password, a very secure password, as you can see. So yeah, of course here you are free to put your name, just call it whatever you want. It's your choice really. And log in automatically, require my password, continue. Okay, and now it's gonna go over the installation. It will take a little bit of time, of course, to install the system here. So it will go through the whole installation, and then we need to reboot it to actually log in to our Ubuntu virtual machine. As you can see, that's a long process, 11 minutes into the video, and we are still creating our Ubuntu VM. In the video where I'm gonna create a VM on Azure, Microsoft Azure, you're gonna see how fast it is, how smooth the process is. It's really like amazing. Like honestly, ever since the cloud industries started to kick in, I never looked back on virtualization software. Honestly, the only problem actually that I think people will complain about is the cost, right? For example, Microsoft Azure, AWS, you can get a free account for up to like some $200 credit or something like that, or equivalent, and then you are gonna be charged per second or per minute or per hour, depends on your pricing model and the cloud service provider. But yeah, to be honest with you, if you worry about price, money, if you have to worry about it, then unless you have a free account, but a free account has to expire someday, right? So yeah, it doesn't hurt to have a virtual machine locally on your computer. It doesn't hurt to have Linux laptop. You can get a Linux laptop for, honestly, like a couple of $100 is all you need to have a Linux laptop, right? Linux is very lightweight. You don't need to spend a lot of money on a Linux laptop. An old ThinkPad, an old Dell machine is all you need. A Raspberry Pi, $50 Raspberry Pi, or $40 is all you need. So, of course, if you don't want to spend any money, just as you can see here, what I'm doing, VirtualBox or VMware Workstation or Fusion. I think Fusion costs a little bit of money though. There is a free version, but there is another paid version, I believe, for Mac OS. So, sorry, I'm just chatting with you while the installation finishes. I don't want to be like radio silence. You will not like me like that, So, yeah. This is how I want, I like lecture, I want to take a new approach in this course, being like kind of like a friendly, you see me in the camera better than the other courses I made where you don't see me, you don't have a face to this guy speaking behind the camera, So yeah, I'm just gonna make it a friendly way from now on as I create other video courses. If you like this way, please tell me in the comments, in the reviews, in the messages on my social media, LinkedIn. If you want me just to disappear from the video in the next courses, also tell me. All right. Just gonna keep waiting. The patience is a virtue, my friend. Okay, I don't want to keep you waiting for much longer, so I'm just gonna pause this video and get back when the installation is done. All right, I'll see you in few seconds. All right, after how many minutes? Like 10 minutes after the pause of the video, the installation is complete, so I'm just gonna click on restart now to log into our amazing Ubuntu virtual machine. All right. Okay, please remove the installation medium. So device, it's already removed, so I'm just gonna press enter. Okay, now we are booting into our Ubuntu virtual machine. Hopefully everything goes smooth. I don't want to go over this process again. It's too long of a process. Of course, one thing I just want you guys to know here. Currently, we are running Ubuntu in a graphical environment, like a GUI, graphical user interface. This is not needed for the course. You can run a GUI-less Linux virtual machine. You just need access to a virtual machine, right? You don't need a GUI in this course, of course, okay? But some people like to use a GUI, and I don't blame you. Being a nerd and a Linux admin, I don't really like GUI. I'm just working in my terminal all these years. I got used to it that I hate graphical user interfaces. This is how you know a real Linux administrator. Real Linux admins do not like GUI. It's a fact. Okay, just taking some time to finish booting up our Ubuntu VM. Awesome, so yes sir. My very secure password. And we are in. Just let's give it a few seconds to celebrate. Here you go. We are in an Ubuntu virtual machine. Done. Here you go. So I can just go to the terminal to prove that everything is good and dandy. Yeah, you can run uptime command. 2 minutes now, up and running. Who am I? I'm Spider-Man. Okay, so yeah, we created successfully the Ubuntu virtual machine. Good job. Now that's it for this video. I'm gonna see you in the next video how to create a VM or an Ubuntu virtual machine on a VMware workstation, just to give you a variety of choices here. I'm just gonna shut down this. I'll see you in the next video. Ciao. Hello everyone, and welcome to module number 1, installing Docker on Linux. In this module, we are gonna cover 4 different topics. Number 1, how was life before containers? Number 2, how is life now after containers? Number 3, you will learn the differences between a Docker container and a virtual machine. And number 4, you will learn how to install Docker on Ubuntu. So let's get started with topic number 1. How was life before containers? Okay, so developers used to have a very hard life actually before containers. They used to suffer a lot. So in the application development lifecycle, imagine life before containers, right? If a developer, for example, is installing Apache on Linux, it will be a very different process than installing Apache on a Mac OS or Windows. And depending on the client needs, the developer may have to do that 3 different times, right? So if the client needs support for the entire suite of operating systems, like for Mac OS, Linux, and Windows, the developer may have to do a lot of redundant work, install Apache on 3 different operating systems, and it's actually different process to install Apache on Linux versus Windows versus Mac OS. Okay, so it used to be a very hard life before containers. And also, it's not just the installation process. Package dependencies is a nightmare, okay? It's even a nightmare when it comes to various distributions in Linux, let alone different operating systems like Mac OS versus Linux versus Windows. Okay, so life before containers, developers used to fix a lot of package dependencies, whether working on Windows, Linux, or even Mac OS. Okay, so different applications like an Apache or MySQL or MySQL would need different packages, and these packages will actually differ if you are developing on Windows or Linux or Mac OS. And even within Linux, it will differ if you are using Fedora, Ubuntu, Red Hat, SUSE. It will be very hard, okay? So package dependencies. used to be very difficult to fix and to track in life before containers. So as I said, many steps actually can go wrong, whether it's package dependencies, whether in its installation process, and many different things. And you will actually you will hear a lot of developers saying, it works on my machine. This used to happen before containers, right? Like, I mean, the client will be very frustrated at the developer because sometimes the developer will develop an application and then he will send it to the client to test it, and the client will say, oh, it's not working. And the developer will just say, okay, it works on my machine. What can I do, right? So this used to be the life before containers. As you can see, it's very chaotic. It's not very, a lot of steps can go wrong, whether it's installation process, whether it's package dependencies. And I mean, we are very happy not to be living right now in the life before containers. Okay, in the next video, I will explain the second topic, which is life after containers. Until then, ciao. Hello everyone. So, how about life now, after the invention of containers? Well, I'm happy to say that life right now is much easier than life before the invention of containers. Why is that? Well, a container actually solves all the problems that I mentioned in the previous video. So a container is pretty much an isolated environment. It will contain the application, the configuration for the application, which is the application configuration, and also the startup script. So by creating that own isolated environment, you actually made it much easier to develop as a developer, okay? Why is that? Because now there is no package dependency problems, okay? This actually solves the idea that, well, the installation process will be different across various operating systems. Well, we don't even care about this anymore because right now there is an isolated environment, which is a container, and this isolated environment contains all what you need for this application, whether it's the application itself, whether it's the application configuration, or even the startup script, okay? So now the installation process is the same across all operating systems. Basically, with the invention of containers, you just use one command, one Docker command to install the application. And this one Docker command is the same whether you are on Windows, whether you are on Mac OS, or whether you are on Linux. Of course, and it's the same thing if you are using different or various distributions of Linux. So life after container is amazing. By creating this isolated environment that we call container, that contains the application configuration, and the startup script, we got rid of all the headache and all the problems that developers used to face, and of course the client used to face as well before the invention of containers. So now the client is happy because the developer will no longer say, it works on my machine, okay? And of course the developer is also very happy because the client is not as frustrated as life before the containers invention. All right, so that's it for this video. I'll see you in the next one. Ciao. Hello everyone. So what is the actual difference between a Docker container and the traditional virtual machine? You may be asking this question right now. Okay, so to answer this question, you will need to learn a couple of things. Number one, all operating systems have two layers, not counting the hardware, of course. So the first layer is the operating system kernel, which makes it possible for the software, applications, and the hardware to communicate. And the applications layer, whether it's a graphical user interface, for example, like GNOME on Linux, okay, or KDE on Linux, or whether it's a like a MySQL database application or a web application like Apache, Tomcat, for example, or MongoDB. Okay, all these are examples for applications. So all operating systems have two layers: the OS kernel and the applications, and that's for Linux, Windows, and Mac OS. All of them have OS kernel and application layer. Okay, so now what is the difference between a virtual machine and a Docker container? Well, both for both virtual machine and Docker, they actually virtualize something, but this something is different. So for a virtual machine, virtualization happens on the two layers: the operating system kernel and the applications. Okay, so a VM, a virtual machine, virtualizes the two layers: operating system kernel and the applications. On the other hand, a Docker container only virtualizes the applications layer, which is the second layer. Okay, so by doing that, okay, and of course you may be telling me, how is that possible? Well, there is a lot of like technicality behind it. Actually, Docker containers uses something called C groups, which is technology based on Linux actually, which is control groups, but I'm not going to explain that. That's actually going to take us hours to explain. Anyways, so Docker, by virtualizing only the second layer, which is the applications layer, that makes it much smaller. So Docker images are much smaller than a whole virtual machine, because Docker do not really virtualize the operating system kernel. It only uses the host kernel, but it does not virtualize the kernel itself. Okay, so that makes a Docker container much smaller, or Docker image, and of course I'll explain the difference between image and a container later. Okay, so that makes a Docker container much smaller than a virtual machine. Also speed, of course. So it's much faster to start up and run a Docker container compared to starting up and running a virtual machine. And now, compatibility. So if you are running Linux, you can install and run a Mac virtual machine or a Windows virtual machine. And if you're using or running Windows, you can run Linux or Mac or an Apple OS, Mac OS virtual machine. And finally, if you are using a Mac machine, you can run a Linux or Windows virtual machine. Now, this is not really the case, I would say, with Docker. Even though you can use Docker on Windows or Mac OS or Linux, the problem happens sometimes with older versions of Windows and Mac OS. So before Windows 10, actually it used to be really hard to run Docker, because as I said, Docker is actually based on C groups, which is a Linux technology. So before that, before Windows 10, it used to be very difficult to run Docker, but they also invented something called Docker Toolbox to support running Docker on Windows. So this is where kind of virtual machine wins. Basically, you can run any virtual machine on any operating system host. It used to be, back in the day, that Docker cannot run on Windows 8, for example, but with the invention of Toolbox, you can still run Docker on Windows. But in this course, I'm only gonna show you how to install Docker on Linux. As I said here, it used to be very difficult to use Docker on operating system like Windows, old of course, Windows 10 and 11, and after that it's much easier and and it's doable, but it used to be very difficult to run Docker on an old kernel of Windows, like Windows 8, XP, all of that of course. But there is something called Docker Toolbox that you can use, and it supports older version of Windows. Okay, so that's pretty much the difference between a Docker container and a virtual machine. Ciao. Hello everyone. In this video I'm going to show you how to install Docker on Ubuntu. And as you can see, a lot of commands that we need to run. Okay, so actually let's get started. For you, if you are using Windows or Mac OS or even Ubuntu like me, you can just Google install Docker on Mac. And you can just follow the documentation. Super simple. Okay? Same thing for Windows. Install Docker on Windows. Alright, same website, docs.docker. Everything is documented and beautiful like you see here. For me, I'm gonna just do install Docker on Ubuntu. Okay, so I'm gonna follow this documentation, and I actually just copied over all these commands in a text file here. Okay, so I'm gonna start with the first command, copy here. I'm logged into my virtual machine, Ubuntu virtual machine. As you can see, 2204 long-term support. Okay, so updating the repos. Let me get the second command ready. I'm installing few certificates and keys here. Okay, let me now run the make directory command. So all of this is on the documentation website. I'm not doing anything from my mind here. I'm just copying over from the Docker website. Okay, everything seems to be stable and working up until now. No errors. Okay, did this. Another update for the repos. And here is actually the installation. Okay, so this will actually install Docker engine. And there is actually two more commands that I use that's not in the documentation. I basically give access to my user, which is Elliot. Of course, Elliot, this is my user name. You have to use your actual username. Okay, I just use Elliot because I'm a big fan of the Mr. Robot TV show. If you know Mr. Robot, I highly recommend you watch Mr. Robot. Okay, just waiting for the Docker engine to be installed. Okay, so up until this moment, I'm done with the documentation actually. Alright. Okay, just waiting a few more seconds here. Shouldn't take that long. Okay, come on. Come on. Almost done here. Alright, it's done. Now I'm just gonna add my user to the Docker group. Okay, I'm gonna use sudo, of course. Docker group, add Elliot, and I'm just gonna do new group to update. Alright, so now if I run the command systemctl status docker, it should be up and running. And that's it. This is how you install Docker with Ubuntu. I'll see you in the next video. Ciao. Hello everyone, and welcome to module number 2, running your first container. In this module, we are going to cover 3 different topics. Number 1, how to run a Hello World container. Number 2, you will learn the differences between a Docker image and a Docker container. And finally, you will learn how to run a Redis application container. So let's get started. So to run a Hello World container, you only need one command, which is docker run hello world. As simple as it can get. Let's actually do it. All right, so hopping over to my virtual machine, I'm gonna do docker run hello dash world, and that's it. Hello from Docker. It's basically a welcome message from Docker, and it's basically used as a troubleshooting guide to know that your Docker installation is actually successful. Okay, now if you run the docker ps-a command, it will actually tell you that we just ran the Docker container 20 seconds ago, hello world image. Okay, and I advise you to go to the man page, the manual for docker run, take a peek, and docker, and also docker ps command, and also take a peek. Okay, because we are gonna use these commands forever in this course, of course. All right, that's it for this video. I'm gonna catch you in the next one. Ciao. Hello everyone. So a lot of people use the word Docker image and Docker container interchangeably, but actually they mean two different things. Okay, a lot of people get confused about what is the difference between a Docker image and a Docker container. And here in this video, I'm gonna explain the difference. Okay, so a Docker image, it's basically the actual package. Okay, so think of a Linux image and an Alpine or an Ubuntu image. It's basically has the actual package in it. Okay, and think about an Apache or MySQL image. It contains the actual application in it. Okay, so it's basically like an artifact that can be moved around, and it can exist without a container. So again, what is an image? It's basically the actual package. So MySQL or MySQL, if you want to say it this way, it's an image. Apache is an image. MongoDB is an image. Redis an image. An Ubuntu or Alpine is a Linux image as well. Okay, so all of these are images. Now, what is a container? Well, the container basically use layers of images to start the application. Okay, and basically there is something called a base image, which is most of the time, 99%, it's a Linux image. For example, you can use a MySQL image, or like download a MySQL image, which will consist of layers of images, the dependencies. Okay, these can include Linux, Alpine, or whatever Linux base image is, and also it will contain whatever number of images that MySQL, or whatever number of packages you can actually say for MySQL to run or MySQL to run. Okay, so a container uses layers of images, okay, to run the application or to start the application. So now, an image can exist without a container, like a Linux image. You can download a Linux image on your machine, or a MySQL, or an Apache, or whatever image you want. You can download it on your machine. Okay, now when you actually run the application that is based on that image, this is now called a container. Okay, and a container is basically non-existent without an image. A container uses layers of image to start the application. Okay, so again, what is the difference between an image and a container? An image is basically the actual package you can download. It can exist without a container, but a container contains, okay, it's called a container, so it contains layers of images, and that is used to start the application. And of course, a container can never exist without a Docker image. Okay, so that's pretty much the difference between an image and a container? Well, something so simple you actually can differentiate between the two. If it's up and running, it's a container. If it's just hanging around on your machine, it's basically an image, okay? If it's something that's up and running, application up and running, it's a container. If it's just hanging around, using some space on your machine, it's just an image, okay? I hope you enjoyed that video. I'll see you in the next one. Ciao. Hello everyone. In this video, I'm gonna show you how to run a useful container, which is a Redis application container. In the previous video, I showed you how to run a hello world container, which is pretty much only used for troubleshooting purposes and to making sure that Docker actually runs. Okay, so let's do it. It's a simple command, one command only, docker run Redis, as simple as it can get. So let's do it. So here on my virtual machine, I'm gonna do a docker run Redis. So it's unable to find the image locally, so it's gonna pull it, download it from the Docker Hub. Basically, what's happening here is that Redis, which is the application, it needs a lot of different packages, right? Images. All these images are being downloaded, as you can see right now. Okay, so everything that Redis needs is being downloaded. Everything is done. Now it's accepting connections. So that's it. This is how you run Redis, as simple as that. And here, if we kill it, Control C, you can see with the docker ps command that Redis was just up and running 23 seconds ago. Okay, that's all you need to know for now. Of course, we're gonna go into much more detail later on. Until then, ciao. Hello everyone, and welcome to module number 3, Essential Docker Commands. In this module, you will learn all the Docker commands you need to run and manage your Docker containers. So let's get started. First, you will learn how to list your Docker images. And this is a very simple command, docker images. Let's actually do it. Okay, so I'm gonna run docker images. And as you can see here, I have two images, Redis and Hello World. And these are the two images that we downloaded from the Docker repositories, Docker Hub. Okay, that's it. If you want to know more about it, you can check the manual page, man docker-images. And you can see all the different options that you can use with the docker images commands. That's it for this video. I'm gonna see you in the next one. Ciao. Hello everyone. In this video, I'm gonna show you how to list Docker containers, okay? So, to list Docker containers, you can use the docker ps command. And as you can see, Docker adopts the Linux command ps to list the processes, okay? All right, so it's very, very simple. Let's try it. Here, I'm gonna use a tmax session to break or divide my terminal up and down. If I do a docker ps command, I see that nothing, okay? There is no containers up and running right now. However, if I do a docker ps-a, I see a lot of containers. So 3 different containers that ran 24 minutes ago, 3 minutes ago, and a minute ago. Okay, so the docker ps-a, which is an all option, it will show you all the containers, the one that's running right now and the one that stopped or exited, okay? However, if I go down here and I do a docker run Redis, so Redis is right now running, okay? So I'm running a Redis container. If I do a docker, let's just clear the screen. If I do a docker ps now, I can see that Redis is up and running, up for 9 seconds. And if I do a docker ps-a, I will see that I ran 4 containers. One of them is up and running that I just ran right now, and 3 stopped containers. Okay, if you want to learn more about the docker ps command, please check the docker ps manual page. That's it for this video. I'll catch you in the next one. Ciao. Hello everyone. In this video, I'm going to show you how to search for Docker images. So you have got 2 options. The first is basically by going to the Docker Hub website and search for your Docker images there. And the second option will be to run the command docker search. And I will show you the two options, okay? So let me hop over to our friend Google here and just do a search for Docker Hub, which is the online Docker images repository. Now, if I just search Apache, for example, I get the results: HTTPD, Tomcat, Maven, Zookeeper, Cassandra, all right? Now, I can get the same result if I hop over to my favorite command line. I'm a Linux guy, I don't like anything graphical. Now, if I do a docker search Apache, okay, let me actually just pipe it to the less command here to have a better view. Okay, now you can see HTTPD, Tomcat, Cassandra, Maven, and of course, along with the description. So I got the same result, whether by going to the Docker Hub online website or by running the beautiful command docker search, okay? And of course, you can check the man page as well of docker search. All right, so that's it for this video. I hope you enjoyed it. I'll see you in the next one. Ciao. Hello everyone. In this video, I'm gonna show you how to download a Docker image. To download a Docker image, you can use the docker pull command. Very simple. Let me show you. Now, let me open my terminal here. So, if I do a docker pull httpd, this will, by default, download the latest Apache version available, okay? As you can see, it's downloading all the images required for Apache, and download is complete. So if I do docker images, can see that the latest, as you can see, if you check the tag here, it downloaded the latest Apache package. Now, you can also, this command is the same. So if you want to be extra explicit, you can do httpd and then latest, which is already implied. So you don't need to do that actually. But let me tell you that they're the same, okay? As you can see, image is up to date. It's not doing anything. Okay, now let me check the Docker images again. Okay, I do have the latest version. Okay, so this command is this command here is equivalent to just not specifying any tag. However, what if you want to install a specific version? You can actually do that. So if we go to the Docker Hub website and search for Apache again, and then take httpd, let's say, for example, you want to install version 2.4, so you have to add the tag 2.4. How do you do that? It's very simple. Just 2.4 colon 2.4. That's it. And it downloaded 2.4. As you can see, I have two different Apache versions here, the latest and greatest and the 2.4 version. You might be asking how come it was so fast downloading 2.4. This is because there is very common, almost 90% common images between the latest version of Apache and 2.4. This is why it didn't actually download anything except that 2.4 image. It did not download any other image because it had everything in common, or 99% of images common with httpd latest, okay? And of course, if you want to check the docker pull man page, feel free to do so, okay? And that's it for this video. I hope you enjoyed it. I'll see you in the next one. Ciao. Hello everyone. In this video, I'm going to show you how to start and stop Docker containers. Very simple. To start a Docker container, you can use the command docker start. And to stop, you can use the command docker stop. So simple. Let me show you. Okay. So now, let me check if I have anything running. Nothing at all, so no containers running. However, if I do the command docker ps-a, as we all know, you can see that I used to have few containers running here. Okay, what if I want to start this Redis container? I can basically get the container ID, which is the first column here, and I do the docker start. Okay, so let me copy it. Okay, let me copy this. Okay, so docker start followed by the container ID, and then run this. This actually started the container. Okay, if I do docker ps, I can see that the container started. Alright, what if I want to stop it? I can run the command docker stop followed by the container ID again here. Okay, so I'm gonna take it, copy, paste. Now the container stopped. If I do a docker ps command, nothing is running. Okay, so simple. So to start a Docker container, you can use the docker start command followed by the container ID that you get from the docker ps output. And to stop it, you can do the same thing, docker stop followed by the container ID. Very simple. And I highly recommend you actually check the docker stop man page and the docker start man page. Alright, that's it for this video. I'll see you in the next one. Ciao. Hello everyone. In this video, I'm going to show you how to run Docker containers, okay? So to run Docker containers, you can use the docker run command. Very simple. Okay, let me show you. Now on my terminal, if I want to run, let's say, for example, Redis, I just do docker run Redis. But here you can see that Redis is up and running, the container is up and running, and it's accepting connections, but it's attached to my terminal. So I can do a Control-C to kill it, okay? Now, if I do docker ps, it's not running because I did Control-C to kill that current Redis session, okay, the container. As you can see, it exited, okay? But if I do a docker ps-a command, I can see that it was running 15 seconds ago. I can use the detached mode, so I can do docker run -d, which is for detached, and then Redis. If I do that, Redis will be running in the background, okay? So if I do docker ps, I can see that Redis is actually up and running currently, okay? So -d, which stands for detached, will make the Redis container running in the background, so it's not attached to my terminal, and I can use it for other stuff. And of course, as always, you can use the man command to check for other options and to read through the docker run manual page. Alright, that's it for this video. I'll see you in the next one. Ciao. Hello everyone. In this video, I'm going to explain to you the difference between a container port and a host port and how the two work together, okay? So you already know by now that you can run multiple containers on your host machine, okay? So you can run multiple Redis containers or multiple Apache or MySQL containers on your host machine. And your host machine has a limited number of ports, okay? Now, conflict may arise if you have two containers trying to map or trying to bind to the same port on your host machine. So what do I mean by that? Look at this picture or graphic here. So you can have a container listening on port 2000, and this container port is being mapped to the host port or being binded to the host port 2000. That's okay. You can also have two containers listening on port 6379. Okay, so I have two containers here listening on port 6379, but they are being mapped or binded to two different ports on the host machine, which is 7001 for one container and port 7000. So this is all good. This works fine. Now, conflict will arise if you actually try to bind to the same host port. So if two containers trying to map to the same host port, this will become a problem. Okay, so let me show you how can this happen. So here we can run a Redis container, and we can do the port binding here. So -p, which stands for port, 7000 here, which is a host port, colon followed by the container port. Okay, and I'm running this in detached mode. So I can run a Redis container and map it to port 7000, and I can run another Redis container with a different version here, for example 627. But if I try to bind the container port 6379 to the same host port, it will cause a conflict. As you can see here, it will say port is already allocated. However, in the second time, if I try to bind it to a different port, so the first one would run just fine. It's being mapped or being binded to port 7000. It will work fine, but the other one, I cannot bind it to the same port. I have to bind it to a different host port, which is 7001, and this will work fine. Okay. And of course, if you do a docker ps command, you will see that the two Redis containers, the latest one and the version 627, they are being mapped to two different ports on the host side, of course. But it's no problem. They are listening on the same container port, but they are being mapped to two different ports on the host side. So let's actually do it. Okay, so here I don't have any containers running. Now, if I do a docker run, and then I specify the port 7000 on the host side, and then 6379 on the container side, which is the default port for Redis, and I will run this, the latest version, of course, for Redis here. Okay, it's working, and you can see the port mapping here, or the port binding. So 637 on the container side and 7000 is on the host side. Okay, now what if I try to run another Redis container with the same host port? Okay, and let's do version, for example, 627. Okay, so first it will download or pull the Redis 627 image, but then something will happen. It will fail because it says port is already allocated. Of course, because you cannot bind two different containers on the same host port. But if I do 7001, this will work just fine. So let me clear the screen and do a docker ps. Now you can see that I have two Redis containers, one with the latest version and one with version 627. Of course, on the container side, they are listening on the same port, 6379, but they are being mapped to two different ports on the host side, which is 7000 and 7001. Okay, simple as that. So just remember, multiple containers can run on your host machine, okay, and containers can listen on the same port, but on the host machine they have to be mapped to two different ports. Okay, so you cannot have two containers mapped to the same host port. Just remember that. Okay, all right, so that's it for this video. I hope you enjoyed it. Ciao. Hello everyone. In this video I'll show you how you can remove Docker images and Docker containers. So imagine if you have downloaded a bunch of Docker images on your host machine, and some of them are unused by any container and they are just using a lot of space. So in this scenario, you can actually free up some space by removing some unwanted Docker images. Okay? So to remove a Docker image, you can use the command docker image rm, which stands for remove, followed by the image name. And here the -f option means that even if you have a stopped or a running container, you will and you still want to delete or remove the Docker image, you can use the -f option. Okay, so this is the fourth option that will remove the image even if it was used by any container, whether it's a running container or a stopped container. Okay, this is for the Docker image. Now you can also remove a container, whether it's being running or whether it's a stopped container. You can use the command docker container rm followed by the container ID or even the container name. And I'll show you how you can actually create a container name later on. Okay, but here just use the container ID. Okay, and of course here the -f options mean you are removing a container even if it's running. Okay, so let's do that. So here, Docker images, to list my images. Okay, let's actually remove the hello world, Docker image rm hello world. Oops, it tells me that there was a container running hello world. Okay, so let me just use the -f option because I really want to remove the hello world. I am not using it anymore. I don't want to use it anymore. Okay, so right now I did remove it. If I do Docker images again, I no longer have a hello world. All right, now let's see our containers. So I do have two running containers, Redis 627 and Redis latest. And of course I have a bunch of stopped containers as well. All right, what if I want to remove the container Redis 627 running the version 627? I can do docker container rm. If I don't use the F option, so here I have to use a container ID, of course. Let me clear the screen to make everything just much better. So let's do docker ps. I have two running containers right now. One with this container ID, which is version 627 of Redis, and this one is running the latest version. Let me remove the 627 version. Okay, so to do that, I can do docker container rm followed by the container ID. Of course, it's telling me you are removing, it's giving me a warning here, right? It doesn't want to remove the container because it's right now it's actually running. So it tells me, are you actually sure? To do that, you have to use the -f, which is the fourth option. Okay, so I'm going to use it, docker container rm -f followed by the container ID. Here we go. It's deleted. If I do a docker ps again, I can see that I only have the latest and greatest version of Redis actually running. Okay, so that's it. Again, to recap, to remove an image, you can use the docker image rm command followed by the -f if you want to force it. And to remove a container, you can do container rm command followed by the -f and the container ID. Okay, and to know more about this command, you can use the docker, of course, the man page. So docker -image -rm. You will learn more about it here, and man docker -container -rm. You will learn more about the command here as well. Okay, so that's it for this video. I hope you enjoyed it. See you in the next one. Ciao. Hello everyone. In this video, I'm going to show you how you can troubleshoot and debug your Docker containers. So maybe one of your Docker containers is not running properly. You may want to check the logs of this container. To do that, you can use the command docker logs followed by this container ID or the container name. And do not worry, I'm going to show you how you can create a Docker container with a given name. Or you may want even to connect to that container, and to do that you can use the command docker exec. So here I use a docker exec command followed by the options -it, which stands for interactive terminal, followed by the container ID or the container name, and then followed by the type of shell that I'm connecting with. And here I will use bash. Okay, so let's actually do that. So if I do docker ps command, I can see I only have Redis container running. Let's actually create a new container. So I'm going to create an Apache container. So I will do docker run in detached mode. I'm going to give it a name. So --name, my web app. Okay, that's how you give a container a name. And then the image will be HTTPD, of course. Alright, so docker ps. Now I have an Apache container running, and you can see the names here. Under names column, I have my web app. And here, of course, if you do not specify a name, for example, the Redis one, I did not specify a name before, so it gives me just a random name, right? A random generated name, randomly generated name, okay? Alright, so now if I want to check the logs of this Apache container, I can do docker logs followed by either the container ID. Okay, as you can see, this is the log that I'm getting here. I have problems with DNS, as you can see. Or now, so I can also check the logs by using the name, so my web app. So I got the same logs, alright? So again, Docker logs can work by either container ID or container name for this matter, alright? Let's actually do it for the Redis one as well. So Docker logs. Okay, let me get this container ID for Redis. As you can see, this is the log I'm getting. Or I can even do the name, which was randomly generated. So it's called nervous _ BOYD. I'm getting the same logs, okay? Now, if I want to connect to my Apache container, I can do the docker exec command followed by the interactive terminal option -it, followed by the container ID or name. I'm going to use a name for this matter, it's easier, and then the type of shell. I'm using bin bash. Here we go. Now I'm actually inside of my container, okay? As you can see, I'm inside my container. Even the ps command is not found. As you can see, I'm inside my container, but the ps command is not found, which gives you an idea that a container is much smaller than a virtual machine. Okay, but I can do an ls command, of course. You can see here. Okay, so right now I am inside of my container. And this container is actually an Ubuntu container, okay, as you can see. So this Apache is running an Ubuntu base image. Alright, so I'm gonna exit out of my container and I'm back here, okay? Let's try to, so docker ps, I'm gonna now connect to my other container, the Redis one, so nervous _ BOYD, okay? This is the name of the Redis container, and I'm also using bin bash. Okay, right now I'm inside of my Redis container. Okay. Okay, right now, as you can see, I'm inside my Redis container. Alright. So that's it. That's how you can connect your containers, and that's how you can check the log files. Of course, you can check the manual page. So docker logs. As you can see, it fetches logs of a container, and the docker exec command as well. You can check the log, the manual page. As you can see, -I is for interactive and T for the terminal. Okay, all right, that's it for this video. Ciao. Hello everyone, and welcome to module number 4, running an Apache web server with Docker. So this module here is meant to be a little bit of a break for you. Okay, so in this module you are not really going to learn anything new, but rather you will put everything that you have learned so far into a meaningful project and to practice what you have learned. Okay, so in this module it has 3 different topics. Number 1, which you already know how to do, running an Apache container. Number 2, which you also know how to do, connecting to your Apache container. And then finally, we will edit the index.html page for our Apache container. So let's get started with running an Apache container. Okay, so here we will run an Apache container in a detached mode, of course, and we will do the port binding, 80 on the host port and 80 on the container port or the container side. So port 80 will be the host and port 80 will be the container, and of course this port 80 is the default port for Apache, okay, for the web server. And we will also give it a name, my web server. All right, so this is simple. Let's actually do it. Okay, so we will do docker ps. I only have Redis running right now. So let's do docker run detached mode. Let's do port mapping or port binding. So 80 on the host side will be binded to 80 on the container side of things. And we'll give it a name, my web server Apache image, of course. Okay, so docker ps, I have my Apache container up and running, and that's it for this video. Simple. Hello everyone, in this video I'll show you how to connect to your Apache container that you have just created, okay? And you already know how to do that, okay? So to connect to your Apache container, we will use the docker exec command. So docker exec followed by the -it option for interactive terminal, followed by your container name or container ID, and then finally the type of shell you are connecting with, bash, okay? So let's do it. So docker ps, here is my lovely Apache container, my web server, as you can see here, okay? I will do docker exec -it my web server, and then the type of shell, bash, and I am inside my lovely Apache container. That's it. Hello everyone. In this video, we are going to edit the index.html web page from inside our Apache container that we have created and connected to, okay? And for that, we are going to use the Nano text editor. But of course, you are free to choose whichever text editor you would prefer. Okay, so let's get started. So here, I am already connected to my Apache container from last video, and I'm gonna run a simple find command to search for the index.html web page on the container, redirecting the errors to div null. And I see the index.html is under the htdocs directory. So I'm gonna go to htdocs, and I can see the index.html here. It contains only one line, it works. So now if I go to my host machine, which happens to be the Ubuntu virtual machine, and open up my web browser, okay, I can actually see that if I go to my local host IP address, I can see the line, it works. So how is this possible? Well, remember there is a port binding between the host port 80 and the container port 80. So any traffic on the host on port 80 will be redirected to port 80 on the container side. There is a port mapping or port binding between port 80 on the host and port 80 on the container. Okay? This is why I'm able to see it here on my host. All right. Now let's edit the index.html. So I'm gonna use Nano text editor. Well, it's not installed, so I'm gonna install it on the container. So first I'm gonna update the repo list, and I'm just gonna run install command for the Nano text editor. Remember, all of this is happening inside our container. So I'm actually installing Nano inside of my Apache container, which has an Ubuntu based image. Okay, amazing. Now I can actually open up HTML index.html page and I can edit it now. So let's actually add an image, make it more interesting. So just gonna Google a Docker image, and then let's kinda get any fun image here. So let me just get this image, view the image source, and I'll copy it here. Okay, so I'm gonna create an image. Amazing. I'm gonna save and exit. Okay. All right. Now, if I go to my host, open up a private window here, and I can see my image. As you can see, zoom out a little bit, and you can see it. Okay. So it was very simple to edit the index.html, and I can see it from my host machine because there is a port mapping. Remember, there is a port mapping between port 80 on the host side, redirecting traffic to port 80 on the container side. And that's it for this video. Ciao. Hello everyone, and welcome to module number 5, running multi-container applications. In this module, we are going to cover two different topics. Number 1, running a MySQL database container, and number 2, running MySQL and Apache with Docker Compose. Okay, so let's get started with number 1, running a MySQL database container. So to run a MySQL database container, we are still going to use our beloved command docker run, the -d in detached mode. We'll give it a name, mydb, and we will do a port mapping 3306 on the host side to 3306 on the container side, and port 3306 is the default port for MySQL in case you don't know. And we will also use the -e option, which will be setting the environment variable. So -e stands for environment, and we will be setting the environment variable for the MySQL MySQL underscore root underscore password. Okay, we will set it to whatever password you would like, and then after we run the MySQL database container, we will connect to it and we will show the databases inside our MySQL container. Okay, so let's do it. So I'm gonna do a docker run, detached mode. I'll give it a name, mydb. We'll do port mapping from 3306 on the host side to 3306. The container side, we will set the environment variable MySQL underscore root underscore password equal to pass. Okay. Of course, here you can set it to whatever password you would like, and we will use the MySQL image. So it's gonna download it. right, it's gonna take a few seconds. Okay. Almost done here. Okay. So now, if I do a docker ps command, I can see the MySQL container is actually running. Okay. So let's actually connect to it. I will do a docker exec command, mydb. Alright, so now I'm inside it. I will do a MySQL command here. Amazing. If I can actually do a create database, or actually can run the command show databases. As you can see here, I can even do a create database our db1, and then I can do a show databases. You can see that db1 is created. Alright, so that's it for this video. We have created a MySQL container and we have connected to it. Alright, I'll see you in the next one. Ciao. Hello everyone. In this video I'm going to show you how to create two containers, MySQL and Apache, with the Docker Compose tool. So up until this point we have been overusing and abusing the docker run command. Every time we need to run a container, we use the docker run command. However, this is not very easy to maintain. For example, let's say you have an application that is dependent on 10 different containers or 10 different services. Are we gonna use 10 different docker run commands every single day to start our application? Of course, this is not easy to maintain and it's very chaotic. And for that reason, the Docker Compose tool was invented. So the Docker Compose uses the YAML format file to list all the containers that you want to run in this file. Okay, so here we have a file called myapp.yaml, and we are using the latest version of the Docker Compose available right now. And after that, under services, under the services tag, we can list all the containers that we want to start. So here I will create a container called or named my web server. It will use the Apache HTTPD image, and we will do a port binding 80 from the host to 80 on the container. Similarly, we'll create or we'll start a MyDB or a MySQL container. It will be named MyDB. It will do a port binding from 3306 on the host side to 3306 on the container side, and it will also set a environment variable MySQL underscore root underscore password. Okay. After that, after you have created a file, you can use the Docker Compose command to start up and to stop your containers. Okay, so let's actually get started. So here I don't have any containers running. So let me create my app file, .yaml file, and I'm going to use the latest version 3.8. Okay, and the services, under services tag here, I'll create my first container named my web server. It will use the image HTTPD, and the ports, it will do a port mapping 8080. Alright, similarly I'll create the MySQL container named MyDB. It will use the image MySQL or MySQL, and the ports, it will do the mapping from 3306 on the host side to 3306 on the container side. Okay, and it's also set the environment variable MySQL root password. Okay, pass. All right, so the dash here means a list, of course, because you can do multiple port binding, and you can also set multiple environment variable. Okay, after I'm happy and content with my file, I will save it. Okay, and I'm gonna do the docker compose command, specify my file here, -f for file, so YAML file, and then I'm gonna start them up in detached mode. So as you can see here, it's creating my web server and my DB containers. So now if I do a docker ps command, I can see that both are up and running. Magical, right? This is very fantastic. Now if I want to stop them, I can also use the docker compose command followed by my file, and then I'm just gonna say down, and this will be bringing both containers at the same time here. Okay, so if I do a docker ps, they are no longer running. Okay, so actually docker compose is very powerful and it's very useful, and it makes it very easy to maintain, and the developers to maintain all their applications with docker compose. Okay, that's it for this video. See you in the next one. Ciao. Hello everyone, and welcome to module number 6, building your own image using Dockerfile. This module is honestly one of my favorites, and you're gonna see why by the end of this module. Okay, so in this module we will cover two different topics. Number one, we will define what is a Dockerfile, and finally number two, you will be able to build your own image using Dockerfile. Okay, so let's get started. So what is a Dockerfile? Basically, a Dockerfile is a text file that contains a set of instructions to define and customize your own Docker image. Okay, so one of the instructions that you can use is the from instruction. So this from instruction will define the base image. For example, you want to create an Ubuntu image. Okay, now another instruction is the run instruction, which will basically run commands from inside this image. So for example, let's say you want to create a Docker image that has Apache installed on it, MySQL, Nano editor, Vim editor. You can do all of that using the run instruction or the run command here. Okay, another very important instruction is the copy instruction, which can actually copy files from the host to the container that is based on your image, of course. Okay, and finally here we have the env, which is the environment instruction that can set your environment variables, like the case with the MySQL. For example, you can set the environment variable MySQL underscore root underscore password. All right, so that's it. A Dockerfile is basically a set of instructions. It's a text file that contains a set of instructions for you to define the skeleton and to define and customize your Docker image according to your own flavor and according to your own needs. All right, in the next video, you will actually see how you can create this Dockerfile to create and build your own Docker image. Until then, ciao. Hello everyone. In this video, you are going to build your own Docker image, okay? So first, we will create the Dockerfile, and it has to be named Dockerfile, okay? This is the requirement, actually. It's a requirement, it's a must. You have to name it Dockerfile. And as you can see here, I have 6 different instructions. The first one, I'm setting my base image to Ubuntu, and of course everything that begins with a hashtag is a comment, so you actually don't need it, but it can be useful, of course, for future use to know what you are trying to do. Okay, all right, so the first instruction here, I am setting my base image to Ubuntu. So I'm building a Docker image that is based on Ubuntu. And after that, on my Ubuntu image, I will update the repository sources list using the run instruction, and I will install Apache using the run instruction. I will also install the Vim editor using a run instruction, and also I'm going to create a backup directory here /home/backup using the run instruction. And finally, I will copy a file from my host machine to my container slash home slash backup, or to my image actually here slash home slash backup. Okay, simple as that. After I'm happy and content with my Docker file, I can actually build it. So I can build my image using the docker build command. So docker build followed by the dash t, which is a tag. I'll give it a name, my web image, for example. And dot here means that the Docker file is under the current directory. Okay, and then finally I will run a container based on my new customized image. So let's do this. Okay, so I'm gonna create a file, Docker file from Ubuntu. So this will be the first instruction. I'm going to update the repositories sources list, and then I'm also going to do a run instruction for installing Apache on Ubuntu, and another one here to install Vim, and another one to create these home slash backup directory, and finally the copy instruction to create or to copy the backup.disk file from my host machine to my image. Destination, of course, slash home slash backup on my image. And after I'm happy with this, I will save, exit. Let me also create this backup.disk right here. Okay, it's an empty file, but you get the idea. And now I can use the docker build command with a dash t, my web image, which will be my image name, and dot for the current directory that has the Docker file in it. Okay, so now as you can see the steps, I am creating my own image. Okay, so it's downloading the Ubuntu image. All right, and going to step number 2, which will be updating the repos sources list. And then step number 3, it's installing Apache. All right, and then okay, it's going through the steps here. It's very fun watching this. It's still installing Apache. Okay, step number 4, it's installing the Vim text editor. It should be fast. All right. Step number 5, it's creating the slash home slash backup. And step number 6, it's copying the file from the host to the image. Destination slash home slash backup. Okay, so now it's done. If I do a Docker, let's just clear the screen first. If I do a Docker images here, I can see that I have my image. Okay, my web image. Now I can actually go do a Docker run my web image. So this will run a container based on my image. And if I go to cd slash home slash backup, I can see the file backup.disk. Amazing. So here I created my own Docker image, which the name is my web image. So I created my own Docker image named my web image, and I ran a container here based on my new customized my web image. Okay, that's it for this video. I hope you enjoyed it. Now you have the skills to build your own customized Docker images according to your own needs and flavor. Hello everyone, and welcome to module number 7, which happens to be our last module for this course: persisting data with Docker volumes. In this module, we are going to go over 2 topics. Number 1, why do we need Docker volumes? And number 2, creating Docker named volumes. Okay, so let's start with number 1. Why do we need Docker volumes? To put it simply, we need Docker volumes because we do not want to lose data. Okay, so If you have created a container, and let's say a MySQL, for example, container, and you have a bunch of databases on that container, and you have removed, or somebody has removed this container by mistake, you will be losing all your data, okay? So we don't need that. But first, let me show you, or let me do a demo for you to see how you can lose data, okay, if you have removed your Docker container by mistake. Okay, so let's do it. Here we are going to create or run a Docker container named cool Ubuntu that will be based on our image, my web image that we just created from before. So here the run-it means -it means interactive terminal, so we're going to run and connect to the container at the same time. Okay, all right, so now if you go to /home/backup, we will create a file, okay, echo hello.txt. okay, simple file that only has one line. Now if we exit from this container and we removed it, so docker container rm cool Ubuntu, this is the name of our container. Alright, the container is removed. Let's create it again now. Okay, so now if we go to /home/backup, you see the hello.txt file is no longer there. Okay, so the data here is lost, and this is basically a very simple demo that shows you if you remove the container without Docker volumes, okay, without named Docker volume that we will actually create in the next video, you will lose your data. Okay, simple and to the point. In the next video, I'll show you how you can create named Docker volumes to avoid losing data if you have removed a container by mistake. All right, until then, ciao. Hello everyone. In this video, I will show you how to persist data and not to lose data by creating Docker named volumes. Okay, so in this illustration, it gives you an amazing idea of how this works. So in our host, we will create a Docker named volume. We will call it my data. All right, and this will mount to a location, okay, on our container. So this is very important because by mounting the Docker named volume, my data, the data will be replicated on both sides, on the container and on the host. So if the container is lost or removed, okay, by mistake, we can still retrieve the data by mounting the Docker named volume in a new container. Okay, all right, so how will this work? We will use the -v option to create a Docker named volume, and then followed by a colon and the path where we will mount it on the container. Okay, so for example /temp. All right, now if you create some data here under /temp, and then we remove the container and we recreate a new container, but we're going to reuse the Docker named volume my data, we can still retrieve the data here. So nothing will be lost. Amazing. Let's actually do it. So we will do a Docker run command. We will call it, let's just call it nice Ubuntu, for example. This will be the name of our container, and we will create a Docker named volume. We will call it my data. We will mount it under /home/backup. Okay, and we will use our image that we created before, our Ubuntu image, my web image. Okay, now enter. Amazing. So Now, if you go to cd/home/backup, all right, we will create a new file. We'll call it echo hello.txt. Okay, amazing. Now, let's exit out of here. If we do docker volume ls, we can see that we have our Docker named volume here, my data. All other volumes here are just randomly generated, okay, for other containers. But here we're using a name, not a randomly generated name like this one, okay? It's very hard to keep track of randomly generated names, especially when they are like hexacodes like this, okay? Now, if we remove our container, let's clear the screen first. So docker container rm-f nice Ubuntu. So we have removed it. Now let's recreate it again. Give it another name, nice Ubuntu 2 for example. But we are using the same Docker named volume, okay? Now if we enter, if we go to /home/backup, we can see the file hello.txt that we just created. So there is no loss of data here, which is amazing news, okay? Now, how is this even possible? Well, if you go to our host machine and do a find command of hello.txt, you will definitely find it somewhere. Okay? So, just doing a find command here. Let's switch to root and do a find for hello.txt and just, okay. As you can see, this is our Docker volume actually. So it's under /var/lib/docker/volume/my_data_data. This is my data. This is a Docker volume here. Our Docker named volume is stored right here, okay? And this is the file. So if you do cat over this file, okay? If we do cat over this file, you can see it's here, hello. All right, so this is how you can create Docker named volumes. You can use the -v option and followed by your Docker named volume, followed by a colon and the destination where you will mount it on your container. Very simple, very easy, but also very, very useful. And that's it for this video. I hope you guys enjoyed it. Ciao. Congratulations. You have now learned all the Docker skills you need to deploy your own applications using Docker. You have now become a Docker master. And as always, ciao.